Okay, it's time to understand the concept of braking distance, which is basically it comes under the concept of friction, and we have been discussing what friction is and why is it produced, and it is pretty important to actually discuss its practical applications. So braking distance is something that we need to work on, and a lot of questions in your exams will be actually based upon this concept of braking distance. So let's actually dig into it. So whenever you're driving a car or any motorbike or any vehicle, right? So you need to apply brakes, right? So for example, I can draw a car here. So this is a typical car from my childhood, and this car is actually going in this direction, right? So you see something, an object that is right there that is right in front of you on the road, and you immediately see that you're sitting there in the car, and you just immediately see that thing, and you just realize that you just need to apply some brakes in order to stop the car, in order to not hit that object that is right there in front of you, right? So you apply the brakes, and how brakes work is a separate thing that there is a whole braking mechanism, but the main reason that brakes actually work is because of the force of friction. So whenever you apply brakes, brakes actually collide with the tires, and they actually stop because there is a lot of friction between the brakes and the tires, and the car actually comes to a stop because the tires are not allowed to roll anymore, right? So you come to a stop, but you don't actually immediately come to a stop. You see or observe, if you have ever driven a car, you can see that the car actually goes some distance forward, right? It skids actually some distance forwards and then comes to a stop. It doesn't actually immediately comes to a stop. It actually goes and skids some distance forward in order to come to a stop. That distance, whenever you just see that object, and then you think that you need to apply the brakes, and that distance is technically called the thinking distance, and then you apply the brakes, and then the car eventually comes to a stop, maybe in the matter of seconds. But that distance that the car actually takes in order to come to a stop while you apply the brakes, it skids forward. That distance is basically called the braking distance, the distance that the car travels after you apply the brakes, and the time and the distance that it travels in order to come to a stop, right? I hope I'm able to explain that the car immediately doesn't come to a stop. It actually skids some distance forward, and that distance is basically braking distance. So why is it important for us to understand the braking distance? Because a lot of car manufacturers are interested in making that braking distance shorter and shorter, because if the braking distance is longer, you might eventually end up hitting that object. The car eventually needs to come to a stop, but the manufacturers don't want the car to instantly come to a stop, because in that case you would just end up banging your head against the steering perhaps, and you would get yourself injured. So you don't want the car to stop immediately, you don't want the car to stop too late, and you want the car to stop at a very appropriate distance. So that distance is basically the braking distance, right? So that braking distance thing is pretty important to work with, and that braking distance, we can denote that with small d for now, right? So that is the braking distance. And for example, the velocity of the car was, like, let's say you were driving at, let's say, 80 kilometers an hour. So you were driving at 80 kilometers an hour, and you see the object is right in front of you, and you just apply the brakes, and then your car comes to a stop at this after traveling this distance, and now its velocity is, first it was 80 kilometers an hour, now it is, let's say, 0 kilometers an hour, so it comes to a stop, right? So its velocity decreases from 80 kilometers an hour to 0 kilometers an hour, and it travels the distance d, and you're also able to calculate the time that it takes for the car to actually decrease its speeds from 80 kilometers an hour to 0 kilometers an hour. And that time period that it takes is, for example, time t, that we're going to denote. Let's say it takes 2 seconds. It takes 2 seconds to come to a stop from 80 kilometers an hour to 0 kilometers an hour. So you know the time, you know the change in velocity that occurred, but you're not sure about the distance, right? So uh, how can you actually calculate this braking distance uh, from all the data that is provided to you? So first of all, what we can say is the acceleration, right? So first of all, or in fact, you shouldn't be actually worried about calculating braking distance. At first, you should in fact be worried about how you can calculate the acceleration or deceleration, to be exact, about this car. So the deceleration is going to be equal to the change in velocity divided by the time that it takes. So the change in velocity is of 80 kilometers an hour, and the time that it takes is 2 seconds, right? So let's actually convert 2 seconds into hours because we are dealing with let's actually not actually take the measurements in kilometers an hour. Let's actually take readings in meters per second. Let's say the car was actually traveling at 10 meters per second, right? And then it comes to a 0 meter per second. So in this case, it went from 10 to 0. So the change in velocity is going to be a 10 meters per second. It came to a stop in 2 seconds. So the deceleration would be 5 meters per second square. So now you know the deceleration, and if you are supposed to write the acceleration of this car, then it is going to be negative 5 meters per second square. So its velocity decreased at the rate of 5 meters per second square. So with that I mean that in each second its velocity decreased 5 meters per second. So in total of 2 seconds it decreased from 10 to 0, right? So the braking distance, how do we actually calculate the braking distance of this? Uh, you know, of this car. So for that we can actually draw a graph. So we can draw a y-axis, right, and then we can draw an x-axis, right? So now we can see that its velocity was actually at 10 meters per second. So this is a velocity time graph. So velocity was at 10 meters per second, and on x-axis you can take the time. So this is 1 second and this is 2 seconds. So this is time in seconds, and its velocity actually came down from 10 to 0 in 2 seconds, right? So in velocity time graph, you can see that it is a triangle. And if you want to calculate the distance that is traveled by the car, the braking distance that we are, worried about all in all this video, and we actually know that you can actually go back and see the VT graph videos, and you can see that the area under this graph will actually give you the distance that is covered. So how do we calculate this? The area under the graph, which is basically the area of a triangle. So area is going to be 1/2 into the base, which is 2, so into the height of the triangle, which is 10, right? So 10 times 2, so divided by 2, or you could just cancel these 2's, and area is going to be equal to 10 units. So this is going to be the distance. So distance is going to be actually 10 meters. So it actually traveled 10 meters in order to, in those 10 in those 2 seconds it actually traveled 10 meters. So it was going 10 meters a second, and then it actually traveled another 10 meters in order to stop in order to come to a stop. So if this box was, let's say, about 30 meters away, it actually traveled 10 meters further. Now it is standing 20 meters away from the rock, right? So this car would actually, if it is traveling at 10 meters per second, if the rock is right there at, for example, 9 meters away, and you apply the brakes, you will end up hitting the object, right? Because the braking distance in this case at this velocity is 10 meters, right? So the braking distance would vary for different velocities. If you're driving slow, it would come to a stop much quicker than it came to a stop if in this case. So you can actually calculate braking distance by drawing a graph, or there are other numerical techniques for that. But it is important to understand what braking distance is, and I hope this video helped you or aided you to actually get the concept of that even better.